Okay, so I had to make a couple changes here. So we're going to multiply into the expression. So remember, this is distribution. Multiply the coefficients and add your exponents. Here I'm just multiplying 2 into 2x plus 1. So again, when I go to do this, that's just going to look like 2 times 2x and 2 times 1. So that's going to give me 4x plus 2. All right, I want to look at the next slide real quick. So here I'm going to start with the second one over here. So this is greatest common factor. So the first step to solving and factoring is pulling out a greatest common factor if one exists. So I have to look at all three terms and see, is there a number that will divide 5x squared, 10x, and negative 25? Well, not all three of them have a variable, but I know that all three of them can divide by 5. So I know that 5 times 1x squared would give me 5x squared. I know 5 times 2x would give me 10x. And 5 times negative 5. So here my greatest common factor is 5. So I pull that out front. And on the inside I'm left with x squared plus 2x minus 5. So that is a recap on pulling out a greatest common factor and also distributing in. Okay, so here's where we're going to start getting into some new things. So there's two different methods you can use to multiply expressions. One is FOIL, or the other is you can use a box. So the first example I'm going to use doing FOIL. The second one I'm going to do box. After that, you can choose whichever one you prefer. It works either way. So FOIL, this is just like a giant distribution problem. So I'm going to take my first term of 2x, and I have to multiply that to everything in the second parenthesis. So 2x times 3x plus 2x times 7. And then I also need to take this negative 1 and do the exact same thing. But this time I'm going to line up the negative 1 on this side. And I'll show you why in a second. So negative 1 times 3x, and then negative 1 times 7. So now I go to multiply this. I'll get 6x squared plus 14x. And then I bring down the negative 3x minus 7. So now what I notice here, if I line it up the way I did, my like terms automatically lined up. So this leaves me with 6x squared. 14x minus 3x is 11x. And then negative 7. So using FOIL, I just distribute each term to everything in the other parentheses, combine my like terms, and there's my answer. If I want to use box, I look here, I have 1 and 2 terms and 1 and 2 terms. So I'm going to make a 1 by 2 box. You've seen this before in like biology. It's just like Punnett squares. So I'm going to take the first and line it up on one side. And then I'm going to take the second one, and I didn't leave myself a lot of room, but I'm going to line it up on the other side. So each box has a term outside of it. So from here I just have to look and say, okay, 1x times 1x is 1x squared. 1x times 5 is 5x. Negative 5 times 1x is negative 5x. And then negative 5 times 5 is negative 25. So I distributed, multiplied everything together. If I look here, these both have just an x with them. So I have x squared. 5x minus 5x, that actually cancels. It won't happen every time, but it does happen sometimes. And then I just left with a negative 25. So there's two examples of multiplying expressions together. Again, choose which one that you like best, and you can do that for the rest of these problems. All right, so like I said, multiplying and factoring are opposites of each other. So this time we start with 3x squared minus 15x plus 18. And this time we're going to factor it back to look like something that needs to multiply together. So I kind of labeled out your steps up here again of label the GCF, pull out a GCF if there is one, label A, B, and C, fill in the star, and then we find our two numbers that multiply the top but add to the bottom. So I just rewrote the star in here so you guys had that to reference right in front of you. So if I'm dealing with 3x squared minus 15x plus 18, Here I do notice I have the greatest common factor. I know that 3 will go into all 3 of those numbers. So I'm going to take a 3 out of each of them. So I know that 3 times 1x squared gives me 3x squared. 3 times negative 5x will give me 15. And 3 times 6 will give me 18. So I have my greatest common factor of 3, and I'm left with x squared minus 5x plus 6 on the inside. So now that I pulled out the greatest common factor, I want to label A, B, and C. So A, B, and C are now going to be what's left over. So I just have 1, negative 5, and 6. So I'm going to fill in the star. So I have 1 times 6 on top, which is 6, negative 5 on the bottom, and 1 on the two sides. So remember, we want to find two numbers that will multiply to 6 but add to negative 5. So if you're looking at this star and you can't immediately think of the two numbers that multiply to the top but add to the bottom, the best way to go about it is just to start with a number on the top. Well, the only things that I know that multiply to 6 are 1 and 6 and 2 and 3. So if it's a positive 6 on top, positive 1 times positive 6 would give me 6, but 1 plus 6 would not give me negative 5. I could change both of them to negative 1 and negative 6, but again, that wouldn't add up to negative 5. So here I notice if I do negative 2 times negative 3, well, that gives me positive 6. And negative 2 plus negative 3 is negative 5. So my two numbers to fill in the bottom are negative 2 and negative 3. So here's the new part that I didn't put in any of our steps. Once we fill in the star, we actually have to write our factors. So you're going to look at the side of the star. So I have 1 over negative 2, and you want to see if that's a fraction that you could reduce. 1 over 2 can't reduce, so it stays how it is. And the same with 1 over negative 3. So to write my answers, I have 3 times, remember that came from the greatest common factor. Now to write my factors, the number on top goes in front of x, and the number on bottom is added or subtracted to x. And then again, the number on top is in front of x, number on bottom, added or subtracted to x. So my answer, or what I would have multiplied together to get that quadratic, is 3 parentheses 1x minus 2, 1x minus 3. So now we need to look at this second example. I have negative x squared minus x plus 2. Remember, twice in your video last night I said you can't have a negative in front. So I don't have a number that I can take out of all of these things, but because of this negative, I want to take a negative 1 out of everything. So negative 1 times x squared would give me negative x squared. Negative 1 times x would give me negative x. And negative 1 times negative 2 So I just did a whole example and thought I was recording and wasn't recording at all. So now I have to redo this entire page. But anyways, so now that you've tried one on your own, we're going to do a couple more examples together before you get your homework. So again, I have your steps kind of labeled out up there. I already drew in the star, but I'm not going to label it this time. I'm going to actually use that star for the numbers. So this next example is x squared minus 11x minus 12. So here, we're going to do, there's no GCF. There's nothing I can divide out of x squared, negative 11x, and negative 12. So I can skip that first step and go straight into just labeling A, B, and C. So A is 1, B is negative 11, and C is negative 12. So from here, I'm going to fill in the star. A times C goes on top, so 1 times negative 12 is negative 12. B goes on the bottom, so that's negative 11. And A goes on the two top sides. So again, if you can't see the number right away, the best way to do this is just list off everything that multiplies to 12. So no, 1 times 12 is 12. I know that 2 times 6 is 12, and 3 times 4. So of these three sets of numbers, I just want to see which ones could actually add to 11. 1 and 12, I know if I was using negatives somewhere, I could get 11. 2 and 6, that's impossible to add to 11, and same with 3 and 4. So if I look at this, to multiply to negative 12, but add to negative 11, I need the bigger number to be negative. So if I do negative 12 times 1, that'll be negative 12 multiplied to negative 12, but add to negative 11. So again, now that this star is filled in, I just need to look to see if I can reduce either side. So we can treat this as a fraction, 1 over negative 12. That actually won't reduce, so I'm going to keep it how it is. And then 1 over 1, it's the same deal. So when I go to write my answer, I can just write x minus 12 and x plus 1. Remember, not writing a number in front of your variable is the same as having a 1 there. So you can either keep putting the 1's in or you can just leave them out. Alright, our next example, 2x squared plus 16x plus 30. This, I notice, does have a greatest common factor. The greatest common factor here is going to be 2. 2 times x squared will give me 2x squared. 2 times 8x will give me 16x. And 2 times 15 is 30. So again, I write my greatest common factor of 2 on the outside, and all of my leftovers stay inside. So when I pulled out the GCF, I label A, B, and C. So here A is going to be 1, and C. Alright, I don't know what's going on. This is acting super weird. We're going to go ahead and skip the one that I super scratched out over here. The one on the left side. What I was beginning to say is there was a first term with a negative in front of it, which we can't have. So I was saying that our greatest common factor has to be negative. And then I was looking at negative 10x squared, 14x, and 12. And I noticed that they all have 2 in common. So to take care of my first term as a negative, I'm taking out a negative 2 of every single term. So I saw here that negative 2, if I divided by negative 10x squared by negative 2, that would leave me with positive 5x squared. Here, 14x divided by negative 2 would leave me with negative 7x. And 12 divided by negative 2 would leave me with negative 6. So my greatest common factor is negative 2. The leftovers are 5x squared minus 7x minus 6. Alright, so labeling A, B, and C. A is 5, B is negative 7, and C is negative 6. So the star, I'm going to use all this room over here. So A times C on top, so that's negative 30. 5 times negative 6. B on bottom is negative 7. And here I have 5 on either side. So I need to find two numbers that can multiply to 30, but also add to 7. So I start with 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. So going through this list, I know there's no way for 1 and 30 to add to 7. 2 and 15 cannot add to 7. 3 and 10, if I use negatives, I can get to 7, but 5 and 6 can't. So if I am multiplying to negative 30, but adding to negative 7, well, I know that the bigger number has to be negative then. Okay, this whole time I've been saying, okay, we have to see if we can reduce the sides now, but we haven't been able to do anything with that so far. This is our first example where we can. So if I look at this, if this is 5 over negative 10, again I've said treat this like fractions. So this will reduce to 1 and -2. I can divide 5 out of both of them. If you look on the right side, I have 5 over 3. 5 and 3 don't have any numbers in common, so I can't reduce them at all, so it stays where it is. So to rewrite my factors, I'm going to use the two sides that I circled plus my greatest common factor. So I started with a -2, and then I have 1x minus 2, and then 5x plus 3. So this is how we're going to factor using our star method.